The computer, the humble backbone of the modern society. It's great, fantastic at numerous tasks, able to do simultaneous calculations at every moment. But there is one thing it can do that seems to defy the logic of its own logic, and that is generate random numbers. How can a device known for its orderliness and repeatability generate something by its own definition as unpredictable as random numbers? But it can. Computers allow you to play computer games which have random encounters, security encryption which needs random numbers to work, or even gambling games which cannot be predictable. There are two types of ways for a computer to generate random numbers: pseudorandomness and true randomness. First, we'll take a look at pseudorandomness. Pseudorandomness is something that seems random to the normal human. However, there is some sort of logic behind it in the form of an algorithm. It's essentially cheating at being random. Most pseudorandom numbers use an algorithm utilizing the modulus function. The modulus returns the remainder of the division of a number. For example, 43 mod 4 returns 3, as 43 divided by 4 is 10, with 3 left over. The most common and easy to implement pseudorandom generator is the linear congruential generator, which follows this formula. Xn plus 1 equals, open bracket, A xn plus C, close bracket, mod m. Constant numbers are selected for C, A, and M. X is the seed and the resultant random number. With each iteration of the algorithm, the previous random number becomes the seed, so more and more random numbers can be generated. As long as good numbers are chosen for C, A, and M, this can produce a long stream of seemingly random numbers. This is great for things like computer games, where the randomness doesn't really matter if it's truly random, just like the human playing the game believes that it is. There are times when predictable randomness is wanted. Many statistic studies and models require a set of random numbers. However, all good studies should be repeatable. If the formula for the randomness and the seed is known, then the set of numbers can be used to check the simulation is repeatable. The other type of randomness is true randomness, and according to its name, this is the real randomness. This is required in such fields as security and encryption. Security would be severely lacking if all one had to do was work out the formula to crack the code. As a computer is nothing but algorithms and formulas, for true randomness, the computer cannot trust what's on the inside, for it is just simply an orderly machine made up of algorithms that can be easily replicated. Thus, it needs to look to the outside, the unpredictable, ever-changing, great big world. In the real world, there are a number of phenomena that are random events. These can be classed into two categories. Things that are local to the computer, for example, when keystrokes are entered by the user, or clock drift. The computer can compare the time between the different clocks on its separate cores to generate a random number. Alternatively, the computer can look at things external to itself. Nuclear decay. Just hook up a Geiger counter to a computer, grab some radioactive material, and the Geiger counter will go off at random intervals. Atmospheric noise. Radio noise caused from natural atmospheric processes such as lightning. The best true random number generators use an external source, such as nuclear decay or atmospheric noise, so that there is nothing internal to the computer which could be susceptible to a security breach. Keystrokes may be sent to the computer's brains at set intervals, and clock drift is not always truly random. Sometimes the clocks may drift in a predictable manner. Most true random sources, like atmospheric noise, take a little while for the computer to get enough data to produce a random number. Atmospheric noise, after all, is mainly caused by lightning, and there would not be enough lightning strikes to generate all the encryption keys in the world. This is called blocking, while the computer takes time to gather enough inputs. Generally, true random numbers captured from these external sources are used as a seed in a pseudo-random number generator. This greatly increases the amount of numbers that can be generated. In conclusion, can computers generate random numbers? By itself, a computer can generate a lot of seemingly random numbers by carefully crafted algorithms. If a true random number is required, then the computer must look outwards and harvest naturally random occurrences to produce something truly random. Thanks for watching. If you like this video, please give it a thumbs up and consider subscribing.